Imagine standing on a quiet beach, staring into the night sky, knowing that hundreds of trillions of stars are out there, and asking the question we've asked for centuries. Are we alone? Tonight, we explore a planetary mystery that may bring us closer to answering that very question. Roughly 124 light-years away from Earth, in the direction of the constellation Leo, there exists a distant world orbiting a red dwarf star. Its name is K2-18b, a planet discovered in 2015 that has, in recent years, captured the imagination of scientists and stargazers alike. Unlike many of the exoplanets we've found so far, gas giants too hot or rocky worlds too cold, K2-18b resides in the habitable zone, the sweet spot around a star where temperatures could allow liquid water to exist. And where there's water, as we know from Earth, there just might be life. Recently, astronomers using the James Webb Space Telescope, our most advanced eye in the sky, have detected something remarkable in the atmosphere of K2-18b. They found signs of dimethyl sulfide, or DMS, and dimethyl disulfide. Here on Earth, these are not just ordinary gases. They are chemical signatures produced almost exclusively by living organisms, most notably by marine phytoplankton in our oceans. That's right. What they discovered are what we call biosignatures, the molecular echoes of life. Let's pause here. Imagine you're on a spacecraft orbiting an alien world. The atmosphere looks hazy, perhaps even bluish-green. You run a scan and you detect gases. Gases that don't just exist naturally, but that on your home planet only come from the metabolism of tiny living organisms. That's the kind of excitement researchers are feeling right now. To understand why this is so significant, let's talk about what DMS is. On Earth, DMS is produced by microscopic marine life, phytoplankton. As these plankton photosynthesize and live their tiny lives in the ocean, they release DMS into the atmosphere. When you smell that faintly sulfurous scent near a beach, that's DMS. And on Earth, it's entirely biological in origin. There is no known natural process, no volcano or chemical reaction that creates DMS in meaningful quantities without life involved. So when scientists looked at K2-18b and found DMS in its atmosphere, it wasn't just a chemical reading, it was a possible whisper from life, from across the void. But we must be cautious. The cosmos does not easily give up its secrets, and nature often fools us. There are chemical processes we may not yet understand, especially in environments vastly different from Earth. K2-18b is not a second Earth. It's larger, about 8.6 times the mass of our planet. It's what we call a sub-Neptune, a type of planet with thick atmospheres and potentially deep oceans, if they exist at all. And the host star, a red dwarf, is smaller and cooler than our Sun. These stars are known for their volatility, sometimes releasing flares that could strip away a planet's atmosphere or affect its chemistry in unpredictable ways. Still, the presence of water vapor had already been confirmed in K2-18b's atmosphere years ago. Now, with the detection of DMS and related compounds, the planet has climbed the ladder from interesting to potentially life-hosting. Let's step back and think about how we detect these molecules. The James Webb Space Telescope doesn't fly to these planets or photograph them up close. Instead, it watches their stars. When a planet passes in front of its star, a small fraction of starlight filters through the planet's atmosphere. Molecules in the atmosphere absorb specific wavelengths of light, leaving unique fingerprints, patterns that reveal the chemical composition. This technique, called spectroscopy, is like reading the ingredients list of a planet without opening the package. And now, in K2-18b's atmosphere, we're seeing those spectral fingerprints, not just of water vapor, but of molecules like DMS, fingerprints that on Earth would point directly to living processes. So what does this mean? Are we witnessing the first signs of alien life? The truth is, maybe. And that maybe is one of the most exciting scientific words there is. Confirmation requires more data, more observations, more models that can rule out non-biological origins. And even if these molecules are indeed formed by life, we don't know what kind of life. It may not be plants or animals or even microorganisms like the ones on Earth. It may be something entirely alien, perhaps life based on unfamiliar biochemistry, thriving in warm oceans under a thick, hydrogen-rich sky. Still, this isn't just about a single gas on a single planet. It's about the process, the leap in our ability to examine the atmospheres of distant worlds, to smell the chemical perfume of alien skies. A decade ago, this was science fiction. Today, it is science, and the implications ripple out in every direction. If life exists on K2-18b, it suggests that life, at least in its microbial form, may not be rare at all. If we can find it 124 light-years away with our first generation of truly powerful space telescopes, perhaps it's out there in abundance, scattered like seeds across the galaxy. It also changes how we think about life itself. Maybe biology is not a quirk of Earth, but a cosmic tendency, an outcome of chemistry given time, water, and energy. Perhaps the universe is not silent, but softly breathing, quietly teeming with life we've yet to know. The next steps will be crucial. Scientists will continue using the James Webb Space Telescope and future observatories to confirm and refine these findings. They'll test alternative explanations, look for other biosignatures, and observe more planets in similar orbits around similar stars. And all the while, we, curious, wondering, earthbound observers, will keep asking, what's out there? It's worth noting that even if life is never found on K2-18b, the discovery of complex molecules like dimethyl sulfide in an exoplanet's atmosphere is itself monumental. It demonstrates that our instruments work, that our techniques are sound, and that our universe continues to surprise us. Every world we study brings us closer to understanding our place in the cosmos. Whether it's a desert moon, a frozen gas giant, or a water-wrapped sub-Neptune glowing faintly in a red sun's light, each is a story waiting to be read. K2-18b has just offered us a new chapter, one that begins not with a roar, but with a whisper of gas, a hint of life, and the dream that maybe, just maybe, we're not alone. Thank you for watching. And until next time, keep looking up.